Hey guys, it's Mr. Schmidt here, and in this video, we're going to look at topic 1.3, the production possibilities curve. This will be pages 13 and then 15 through 20 in your textbook. Multiple learning goals this time. So, we're going to look at defining the PPC, explaining how to use it to show various things like opportunity cost, efficiency, and then calculating opportunity cost as well. Let's go ahead and get started into the content. This is really our first opportunity to look at economic models. In this class, economic models are also called graphs, and it's a simplified visual representation of economic concepts. Graphs or economic models are really good at helping us to understand these really sophisticated concepts in very visually pleasing, simple ways that really help drive the point across. To do well in this class and on the AP exam, knowing these graphs, mastering these graphs are going to be really important. You're going to see a ton of them. This happens to be the first one. And so it's really important every time that you're introduced to a new graph, which is what I'm going to call them from now on, that you really pay close attention. Make sure you understand it inside and out, and of course, ask questions as needed. So, the economic model we're going to look at first is called the production possibilities curve or PPC. Sometimes you'll hear it called the production possibilities frontier or PPF. It's an economic model that shows all the combinations of two goods that can be produced with a fixed amount of resources. And so I want to highlight a couple parts of the definition for you. First is it's two goods, right? So obviously, in the real world, any country is going to produce a lot more than just two goods. But we're just going to focus on two goods to keep it simple so we can understand the concepts without introducing all the complexity that the real world provides. And then the other part is that it's a fixed amount of resources. So we hold the amount of resources constant to allow us to draw the model because if the amount of resources can change, and we'll talk about resource change towards the end, it kind of makes it a little harder. And we'll get to that later. So that is the definition of the PPC. What I like to do with the graphs, so this is the first time we're really working on drawing graphs here, is I'm going to show it to you in parts. And so basically, whatever you see is what you should draw. But we're going to start here, and every graph is going to start with a giant L or the positive axes on the coordinate plane. So we only use the positive parts of the coordinate plane because we're always dealing with physical objects or money, things that have positive values only. So go ahead and draw that giant L. And then the next step is we're going to say that this country only produces two goods, chocolate chip cookies and sugar cookies. And yes, those happen to be my two favorite kinds of cookies. There you have it. But we're going to go ahead and label the axes as the two goods that this particular economy is producing. And then the next thing we're going to do is something we're only going to do once, and that is to scale the graph. And in econ class, we will almost never actually scale the graphs because it's really not useful to us. What's happening between the axes is far more interesting than what's happening on them. But for this particular one, we're going to because it kind of helps us to understand the concepts if we have some numbers. So we're going to say go 1 to 5 on each axis here. And the reason it's 1 to 5 is because we're going to say that this country can at most produce 5 batches of cookies. So some combination of 5 batches. It could be 4 sugar and 1 chocolate chip. It could be 3 chocolate chip and 2 sugar, 5 of one, none of the other. You get the idea. And so if you want to get ahead, just to see if you get it, go ahead and plot all the points that represent the possible combinations of sugar and chocolate chip cookies and then see if you're right. But I'm going to go ahead and reveal the answer to you here. And this is what it should look like. So the yellow dots represent the different possible combinations of chocolate chip and sugar cookies, so 50, 41, 32, and so on. Went ahead and put the dashed lines there just to kind of help us see where the points are and what numbers they correspond to. You don't necessarily have to do that, but that helped me at least when I was making the graph there. So this is a production possibilities curve. In this case, it's a straight line. We'll see one in a minute that is a bit more curvy, but this one is linear. And so the next thing we're going to do is go ahead and label the point three sugar cookies, two chocolate chip cookies. Let's call that point A. And what I want to do is kind of look at point A and point something very important to you out about point A. And that is that at point A, we are efficient. That means we are using all of our resources to produce the product. So we are at 3, 2, we have 3 sugar cookies, 2 chocolate chip cookies, so we are making the most possible batches we can, which is 5, because 3 plus 2 adds up to 5. So any point on the production possibilities curve, in this case, all the yellow dots, represent efficient points, points at which we are using all of our resources. Now what I want to do is look at a point that's inside or below the production possibilities curve, and that would be point B here, which is going to be at 2 sugar cookies and 2 chocolate chip cookies. I could easily picked some other points as well, but this is the one I went with. And not surprisingly, we're going to see here that point B is inefficient. We are not using all of our resources, right? Or at least not using them all well, and we'll get to that in a second. Now, how do we know? Well, because at 2, 2, we're producing 4 total batches of cookies, which means we actually can produce one more. And what's also interesting here is we can produce one more without losing any of the other kind, right? So I can add one more batch of sugar cookies without losing any chocolate chip. I can produce one more batch of chocolate chip without losing any sugar cookies. So this is an inefficient combination. We are not using all of our resources or not using them all well. And we do have some terminology that goes along with that. So, inefficiency is caused by at least one of the following. Either you have what's called unemployment, which you may be familiar with that term in a labor context, but it applies to any resource that is not being used, which kind of makes sense because if you're unemployed, what resource are you not using? Your labor. The other situation you could have that would cause inefficiency is underemployment, a situation in which a resource is not used well. So, in the previous example with the cookies, maybe you have a cookie oven that's malfunctioning. Maybe you have someone like me trying to make the cookies and has no idea what he's doing, or you burn the cookies and you have to throw out a batch. So unemployment is when a resource is not being used at all, and then underemployment is when a resource is not being used well or as well as it could be. And so those are two ways that you get inefficiency. And then finally, in this section, I do want to look at one other possibility here, which is a point that is outside or above the production possibilities curve. And here we're going to label that point C. And point C represents an unattainable combination, which means we need more resources, right? Point C actually is not possible to produce. Why? Because at point C, we're producing 5 batches of sugar cookies, 1 batch of chocolate chip cookies, and that adds up to 6 total batches of cookies, which is one more than the maximum we can produce. So the only way we can get to point C would be to get more resources and actually move the production possibilities curve either up or to the right, however you want to look at it. And we'll talk about that towards the end of this lecture when we get to resource change. So with all that out of the way, let's wrap up this section with a practice question. So go ahead and pause the video, read the question, and see if you can come up with the correct answer. So in this case, the correct answer is E. We cannot tell how Alex should split his time. So, what's important to understand about the production possibilities curve is that it cannot tell us which point on the curve is the most preferable. Points D, E, and A on this production possibilities curve are all equally efficient. So, in other words, all 3 points are using all of our resources, but we have no idea which of these three Alex should pick. And that's why we can't say, for instance, letter D is the correct answer, because we don't know if Alex wants more meals cooked or wants more folding laundry. It may be tempting to go with the E because it's somewhere in the middle, but that doesn't necessarily mean that it's the optimal combination for Alex. We would need more information here to make that determination. So now let's move on to a really important term in economics that we can use in combination with the production possibilities curve, and it's called opportunity cost. Opportunity cost is the best thing given up when making a decision. That word best, you might circle it in your notes. It is the key to this definition. So, anytime you're making a decision, an economist would tell you don't just think about what you're going to get, but also think about what you're going to give up, right? If I go to the restaurant, I can't go see the movie, right? I'm giving that up, right? And so, you really should make a decision if what you're giving up is worth more to you than what you're actually doing, right? And so that's the idea of opportunity cost. And we can apply this to the production possibilities curve. So if we return to our previous example, um, and we go ahead and add point D as in dog to the production possibilities curve, my question here is what would be the opportunity cost for moving from combination A to combination, excuse me, D, right? So in other words, what do we lose here? And the answer is we lose one sugar cookie. At point A, we're producing three sugar cookies. At point D, we're producing two, so we would lose one sugar cookie. Sometimes you also hear the term opportunity benefit, which would mean what do we gain in the situation? And the answer to that would be one chocolate chip cookie. Opportunity benefit isn't something that appears on the AP exam, but opportunity cost definitely does, and it's worth remembering. So, with that in mind, it's important to understand that linear PPCs, like the one we just saw, have constant opportunity costs, and this is due to something called the perfect substitutability of resources. So, there's two things there I want to point out. First of all, what do I mean by constant opportunity cost? I mean that if we go back to the graph just for a second, every time I move to another yellow point, from one yellow point to the next yellow point along the line, I'm giving up the same amount. So if I go, for example, from this point here, which is at 5 sugar, 0 chocolate chip, down to 4 sugar, 1 chocolate chip, I give up one sugar cookie. If I move down again, I give up one sugar cookie, and so on and so on and so on. And so that's the idea of constant opportunity cost. The opportunity cost is always the same when you move from one point to the next point. As for the reason why, this is called the perfect substitutability of resources. It's the idea that you have a situation in which resources used to produce one good or service can easily be switched to producing a different good or service. So, what do I mean? Well, again, if we go back to our example with the cookies, if I decided I wanted to make more chocolate chip than sugar cookies, it's pretty easy to take the resources from making sugar cookies and then move them over to making chocolate chip cookies, right? I can just change the recipe a little bit. I have a lot of the same ingredients. It's pretty easy to do that. And so that's why you get a linear PPC because the cost of moving from one cookie to the other is pretty minimal and it's going to be pretty constant. Okay. Now, another type of PPC that we could have, and this is going to be a completely new graph, is a bowed out or bowed out PPC. And this one, so you can see it kind of bends out away from the origin. And I've chosen two very different goods on the axes to illustrate this. We have soap and we have rockets, okay? Very, very, very different products. And that's to illustrate something that's very interesting about a bowed out production possibilities curve. And that's the idea that a bowed out or bowed out PPC has increasing opportunity costs, right? So the more and more of one good that you produce, the more and more of the other good you have to give up to do so that you can't produce. Okay, that's the idea of increasing opportunity costs. Those costs keep getting bigger. And this is due to the idea of the imperfect substitutability of resources. So, what do I mean here? So, this means that you have resources when they're producing one good or service, you cannot easily switch them to producing a different good or service. So, if I'm making rockets, and then suddenly my company's like, no, 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 we're going to go make soap. That's a really big transition, right? Imagine like your local McDonald's suddenly saying, okay, now we're going to sell pizza, right? I mean, it's food, but it's a completely different product, right? And so that makes it really, really hard to switch. It makes it more costly to switch. And that's the idea of increasing opportunity cost and this imperfect substitutability of resources. So with that in mind, let's do our second practice question of the video. So go ahead and pause the video, look at the question, and then let's see if you got the correct answer. So the correct answer here is going to be D. The opportunity cost of writing another article remains constant as more articles are written. So, how do we know this? Well, it's because the PPC is linear. So, I mean, yes, you have the 18 and 9 on the 9 on the axes here, but that's not going to really change anything. So, it is a linear production possibilities curve. And then finally, we got one more section here with resource change. So the production possibilities curve can actually shift or move. And so in this example, we're moving the production possibilities curve to the left, right? So what does that mean? Well, what I always say in this class is left is less, right is more. Left is less, right is more. So if we're moving the PPC to the left, that means a decrease in the PPC, which means that we're not able to produce as much in this case of either product as before. The maximums, right? If you look at the maximum soap, it's less. The maximum number of rockets, it's less. So what causes that? Well, there's three reasons the production possibilities curve would shift to the left. If we have less resources, we can't make as much stuff. If our resources are not as good, we cannot make as much stuff. If we don't have the right technology to make the stuff, we cannot make as much. So that's the idea of a decreasing PPC or a PPC that is shifting to the left. One more thing I want to point out here is this arrow. Not my cursor arrow, but the arrow I'm circling with it. It's very, very important that you have the arrow when you are making a curve shift in this class. If you do not have the arrow, it will be marked wrong, either by me or on the AP exam by the AP reader. So please make sure you have the arrow pointing in the right direction, indicating that the production possibilities curve is moving either left or it can also move to the right, which we'll get to in just a second. But one little thing I wanted to mention here is that when the PPC shifts left, this is called economic contraction. So just a little vocabulary there. So now let's look at it when it shifts to the right. And so when the production possibilities curve shifts to the right, that is the result of one of three things. Either you have more resources, or better or more technology. And so we shift the PPC to the right, which means the maximum amount of each good that we can produce is increasing. So in this case, we can make more soap and we can also make more rockets at the maximum amounts. And so finally, for this video, before we get to the practice, just keep in mind that the production possibilities curve shifting right is also called economic growth. And so let's do one more practice question. We're going to do something a little different with this one. We're going to do a little free response here. So go ahead and pause the video, do what it's asking, and then I'll show you the correct answer. All right, so a couple things going on here, but the correct answer is going to look like this. And it looks a little different from what I showed you before with a shifting production possibilities curve. So, why is this the correct answer? Well, first of all, it is a bowed out PPC, not linear, because the resources needed to make desks and pizza ovens are very, very different. And so that's why you get a bowed out PPC. So, that's why I picked those two goods on purpose to hopefully point you in that direction. Now, in terms of the way it's drawn with the curve shift, the reason it's drawn this way is, remember, the question said that we only get better technology, which would be a right shift or an upward shift, for desks, not pizza ovens. So the maximum amount of pizza ovens we can make doesn't change, but the amount of desks does. And so sometimes you do get a curve shift with a PPC that's like this, where only one goods maximum is changing and the other one is staying the same. So that's all for this video on the production possibilities curve. Until next time, have a great day.